Ed, over to you.
Thank you, Mike. I appreciate that. First of all, since we do have Rob Bashore on the line, I'd like to hand it over to him for a few words, a little bit about MDA. Rob?
Thank you, Ed. Welcome, everyone. Yes, I'm right now in Mumbai, India, so I hope the sound quality is good enough. But I really wanted to attend this webcast because the MDA tables have been a topic that has always been near and dear to my heart. I remember when they were first released in ASE 15.0.3, and it was really like a completely new window on the inner workings of ASE opened up, because not before had it been able to get data and actually hard metrics on statement execution, table utilization, really things that happen deep down for specific user sessions, for specific tables that we always wanted to know but just couldn't. And now with the MDA tables, they were actually there, very easy to find, very easy to query, and that was all we ever wanted. Also, we thought, because at the end of the day, that was actually quite a lot of data. I mean, I don't remember how many MDA tables there were initially, but I did a quick check, and in ASE 15.5, there's a slide, by the way. Yeah, in ASE 15.5, there were 70 MDA tables with like 983 columns. That was a lot more already than the initial version in 12.5. But ASE 15.7 that has exploded into 84 MDA tables with over 1,300 columns. So we are actually facing a kind of a classical IT problem here, because the MDA tables provide many data points. But as you know, data itself doesn't really, do the job. You need to make it you need to turn it into information in order to use it in a sensible manner. And that describes exactly the, let's say, the challenge around MDA, because there are so many angles you can look at problems inside, or problems, issues, behavior inside ASE through MDA. Because you have wait events, you have I/O numbers, you have SQL text, statement duration, CPU usage. There's so many things you can correlate. So all the data points are sitting there, but the question really is, what are you exactly looking for, and how do you pull all that information, all that data together into information? That's a different way of saying, actually, you need an application to make sense of all that data, to interpret it, to put it into context, to give you an historical perspective, and to correlate it to things going on in your ASE server, because in the end of the day, that's what you need to do to draw any sensible conclusion based on that data. Now, there have been various suggestions to move towards, sort of an application on top of MDA data. I have published some tools on my own website. People have been cobbling together their own things, but to be honest, the best tool I've seen so far is actually what Bradmark has done, because I've worked with Bradmark back in those days to use the MDA tables to basically build that application on top of MDA to pull all that stuff together. And surveillance for ASE has a lot of things that it takes from MDA, and it aggregates over multiple statements, that things that you can see in context that are very difficult to get otherwise. So I'm therefore very happy to see that Bradmark keeps following up with supporting various Sybase data management products and supporting them in surveillance. So the rest of this topic will be done by Ed Stangler, who will take you through the specific features of surveillance for ASE, and specifically about the MDA aspects that surveillance brings to you. So Ed, please show us what you can do.
Thank you very much, Rob. I appreciate it. So today we'll be talking a little bit about the SQL monitoring aspects of MDA, so some of the tables that are in MDA that are specific to SQL monitoring, and talking a lot about the issues surrounding it, a lot about some other tables as well, a lot of issues regarding caveats, performance, but especially showing some of the basics about how to get into the SQL inside MDA. I hope everyone can hear me okay, and hopefully everybody is, as Mike mentioned, doing *6 on the phone in order to mute the line. That'll make it easier for everybody to hear. Firstly, a little bit about Bradmark. Bradmark produces monitoring tools for databases and operating systems and networks. We also have an online reorg tool for SAP R3. We have also the top-tier end-to-end monitoring solution for Sybase in the form of Bradmark surveillance. And we monitor everything from Sybase ASE to cluster additions, IQ, multiplex, to rep servers. Now, there are many ways for an application to execute SQL or T-SQL or store procedures inside ASE. They can be prepared. There can be dynamic SQL. There can be RPC calls. There can be other types of commands that are executed like DBCC. A lot of different ways that you can get SQL into ASE, or you can get commands into ASE. And there are a lot of MDA tables covering many different areas. As Rob mentioned, there's just a huge variety of MDA tables available. But two areas that we're going to cover are, well, one area is we're going to cover SQL, and then the other areas that are available are statement cache, procedure cache, and then there are a lot of other areas as well. Again, if you're on the line, if you can hit *6 on your phone, that would help mute the line. You can *6 on the phone, then that'll mute the line, and that'll make it easier for everybody to hear. Thank you very much. Now, in addition to MDA, there are a lot of other tools available for looking at SQL monitoring, and especially query metrics. Query metrics is a great tool for monitoring SQL. It lets you specifically say which SQL you want to monitor and what metrics you want to get from that. You can get all sorts of things. You can get the I/O, you can get the CPU, all those great things. Query metrics is definitely a great tool for the SQL that qualifies for SQL metrics, for query metrics. Not everything does, unfortunately, but a lot of things do, and that is a great tool for it. And then also another great tool for SQL monitoring is really statistics plan cost. Plan cost is an excellent tool. It really is a great tool that's very much like certain other tools and other products and other databases, I should say. With plan cost, you really can't tell where a particular query plan is really spending a lot of its time. There's some improvements that need to be made. If Sybase can make a few more improvements to plan cost, it'll become really an excellent tool, especially for developers, but also for DBAs, to figure out where the time is being spent in a particular query plan. But the focus of our talk here is going to be MDA today. And this is a talk that I gave over at TechWave 2011. And it's very similar to that talk, and we're going to be talking a little bit primarily about MONSYSSTATEMENT, MONSYSSQLTEXT, and MONPROCESSSTATEMENT and MONPROCESSQLTEXT. This is really going to be the most of what we're going to be talking about. Now, these MDA tables are documented, but how the statements actually look inside MONSYSSTATEMENT or MONPROCESSSTATEMENT is not really well documented. And that's really what, when Bradmark was looking at these tables and figuring out how we're going to do some certain tasks with the MDA tables, we were unfortunately dismayed to see how undocumented, how things look in those tables, and that was one of our goals in doing a lot of research regarding MONSYSSTATEMENT and MONPROCESSSTATEMEnt. There are very important changes to MONSYSSTATEMENT in ASE 15.0.3. Before 15.0.3, as we'll see in a little while, it was really a lot different than in 15.0.3 and later, and really Sybase did a tremendously great job with MONSYSSTATEMENT starting in 15.0.3. And of course, some of the content has changed through the ESDs, and some behaviors have changed through the ESDs. 15.5 is going to be different behavior from 15.5 ESD number 2, for example. And those are going to be different from 15.0.3. Unfortunately, there are little changes they're making, but Sybase does seem to have a clear direction of where they're going with the particular tables. So first we're going to cover some of the basics, then we're going to talk about configuration and current versus recently executed SQL, what the SQL looks like, and some miscellaneous issues. So prior to 15.0.3, MONPROCESSSTATEMENT and MONSYSSTATEMENT had very similar behaviors and many similar problems. They were very much equivalent. MONSYSSTATEMENT really was basically like a historical version of MONPROCESSSTATEMENT, very almost exactly. But in 15.0.3, Sybase added a lot of new columns to MONSYSSTATEMENT, and they changed a lot of behaviors for the better, definitely for the better. But MONPROCESSSTATEMENT still remains at the pre-15.0.3 level, so it's kind of like looking back in time. If you want to see what MONSYSSTATEMENT used to look like, you could take a look at MONPROCESSSTATEMENT, and that's pretty much the behavior that you saw in MONSYSSTATEMENT before. MONSYSSTATEMENT is now usable the data in there is more predictable. If you go through the release notes of the latest versions of ASE, you'll see how they added columns to MONSYSSTATEMENT, but they also talked about how they made everything more predictable, because some of the columns were kind of erratic. CONTEXTID, for example, could go all over the place in MONSYSSTATEMENT before, but now in 15.0.3, they finally decided, we're going to make this a particular way, and they really made it a much more predictable set of statements that show up in there. You can also uniquely identify every single call finally. It actually has a primary key. Before, you could not get a primary key on MONSYSSTATEMENT. You still can't technically get a primary key on MONPROCESSSTATEMENT. With MONPROCESSSTATEMENT, you really have to do a huge conglomeration of columns in order to make something that resembles a primary key. But with MONSYSSTATEMENT, there really actually is an honest-to-goodness primary key available. You can finally write SQL to summarize metrics for a batch or for a procedure call or for commands. It's finally feasible to do something like that, whereas in prior releases it really wasn't a possibility. Even though some people had scripts to do that kind of stuff, it really wasn't possible until 15.0.3. And of course, there are important changes in 15.5 EST2, 15.0.3 EST4, and even more changes that came along in 15.5 EST number 4. This presentation was put together right around the time that 15.7 was coming out. So 15.5 EST4 was about to come out, and it had additional changes that you could see Sybase was going in a particular direction with some of the behaviors. And there's almost certainly going to be more changes on the way. Sybase is continuously improving these tables. It looks like they're continuously defining the behavior, and I think that's a great thing. So currently running SQL are in MONPROCESSSTATEMENT, and is generally identified by KPID, batch ID, and a bunch of 1,000 other columns, unfortunately, because like I said, there isn't a primary key for MONPROCESSSTATEMEnt. So you have to take KPID, batch ID, you can drop SPID if you want. You can take KPID, batch ID, and then you have to take procedure name, and you have to take context ID, and you have to take all these columns because there really isn't a primary key for MONPROCESSSTATEMent. But you can get kind of close. And then, for example, in Bradmark surveillance, we do the best we can with the columns, but unfortunately you end up with a primary key that's almost the entire length of the row. A lot of metrics are provided in MONPROCESSSTATEMent. You can have elapsed time, which is start time, the difference between start time and get date. Elapsed time so far, I should say. It also has CPU time and wait time. Now, CPU time and wait time, unfortunately, don't always add up to elapsed time, especially in MONSYSSTATEMent. And so you end up having this thing called other time. And this is probably a result of some sort of technical reason. I'm not so sure it's really anything other than just some technical reason for it. Maybe there's some sort of overhead of calling something or something like that. Or it could be something else. But if you really have a real problematic statement, CPU time and wait time are going to point you in the right direction. If you have a statement that's really going crazy on the CPU, you're going to see that in CPU time. If you have a statement that's really going crazy on wait time, you're going to see that here. But definitely, in any case, the elapsed time is always going to be accurate. You're definitely going to be able to see like the longest running statements and things like that. Other metrics that you can see in MONPROCESSSTATEMent include logical reads, physical reads, pages modified, rows affected, packets sent, packets received, and from that you can calculate bytes sent, bytes received, those kinds of things. Somebody asked on the question and answer whether there was a PDF available of this. There actually is a download available for the TechWave 2011 presentation archive of this, and I'm sure we're going to make these available after this presentation as well. Now, there's also currently running SQLText in MONPROCESSSQLTEXT. You can join that against MONPROCESSSTATEMent using KPID and batch ID. The entire SQL is divided into several different rows, which are indexed by line number and sequence in line, and line number is also in MONPROCESSSTATEMent. Again, we're covering some of the basics first before we get into some of the more advanced stuff. Now, historical SQL metrics are MONSYSSTATEMent. It's like the history is in MONSYSSTATEMent, but historical can mean recent or ancient depending on activity and pipe sizes. And this is where it really becomes an issue with pipe sizes, because pipe sizes have to be, unfortunately, sized according to other types of considerations. So to really use MONSYSSTATEMent by itself as a historical repository is not really feasible. You really do need to make a copy of MONSYSSTATEMent in order to be able to keep a real good record of things. Because depending on activity, depending on pipe sizes, you may not actually have that much stuff in MONSYSSTATEMent for very long before it eventually gets aged out or something else happens. But you can uniquely identify every single row with KPID, batch ID, and statement number. That is a beautiful primary key compared to the old version. Before 15.03, that wasn't possible, but at 15.03 and later, you can do KPID, batch ID, and statement number as your primary key, and it works every time. Provides the same metrics as MONPROCESSSTATEMENT, but it also includes final elapsed time. So the start time, the difference between start time and end time is there. There's also additional columns for the things like errors and things like that. Historical SQL text is in MONSYSSTATEMENT, the companion table, and you can join against MONSYSSTATEMENT based on KPID, batch ID. And again, the entire SQL text is divided into rows with the sequence and batch being the index for that. Now, pipe tables, MONSYSSTATEMENT, MONSYSSTATEMENT are pipe tables. MONPROCESSSTATEMENT and MONPROCESSSQLTEXT are not. The pipe tables use a circular buffer to keep historical data, which is a great way to be able to keep data and not have any sort of locking, excessive locking going on. Pipe tables include the MONSYSSTATEMENT, MONSYSSTATEMENT, MONSYSPLANTEXT, MONDEADLOG, MONERRORLOG. I think that's all that are currently in there. ASE has write markers, so it always knows where the end of the circular buffer is, and it keeps a place where it's writing to the buffers. Each user session has its own read marker. So every session that logs in is going to be able to see their own little place in the table, and then when they query it again, it'll start from that place again, and then that way they see their own view of the table, in other words, and they're able to see only the new stuff every time you query those particular tables. ASE's write markers go around the buffer, but eventually they overwrite data because it's a circular buffer, and this is where the pipe size is important because the pipe size determines how fast the circular buffer goes around and how much data you actually retain. So copying the data from the pipe table is essential in order to keep a history and to do non-trivial queries. If you're just doing a select star, I mean, you can do that from MONSYSSTATEMENT directly, but if you're doing anything more advanced on pipe tables like group bys or halvings or joins, especially joins, because when you do a join, on a pipe table, if you happen to get a nested loop in the query plan, the first time it scans the table, it's going to get all the data, but the second time it scans it in the nested loop, it could be a big problem. You won't see it. You won't see the same data. You may not see any data at all. But group bys also have issues, and there are a lot of different issues involving non-trivial queries that are problematic with MDA. Some of them involve query plans. For a long time, nested loops seem to be the preferred query plan for queries against MDA, and I think in some version they eventually started forcing it to do merge joins. So that can be an issue, especially for larger amounts of data. CPU usage becomes a big issue, as we'll see in just a moment. And of course, ASE bugs pop up in the past in versions. I'm sure there's going to be more ASE bugs in the future. This always seems to be something with regard to non-trivial queries against MDA. So it really is important to make a copy of the table in order to do some sort of useful type of query against it. And a little bit more about the CPU usage. If you use a table parameter on an MDA table, as defined in MON table parameters, it really reduces the amount of CPU usage you do. So for a lot of tables, you can say select star from this table where, and then maybe one or two columns, whatever is mentioned in MON table parameters. If you do a query like that, internally, Sybase ASE will actually just go directly to those rows. It won't generate the whole table. Or essentially that's what it does, and it reduces the CPU usage significantly. Unfortunately, for the pipe tables, the only table parameter is instance ID. So the different types of parameters you can have for the pipe tables, you have statement pipe max messages, which specifies the maximum number of rows in MONSYSSTATEMENT. You have SQL text pipe max messages, which is for MONSYSSQLTEXT, not to be confused with the max SQL text monitor parameter. It's a totally different item. And plan text pipe messages is also there. And each of these also has an active option that you turn on in order to actually turn on that feature or not. One thing about MONSYSPLANTEXT sounds like a great, fantastic idea. And in fact, Bradmark Surveillance used to use this table a lot. We no longer do anymore because, unfortunately, it just generates so much data and causes so much extra work inside the ASE that just isn't feasible for us to use it in real time, at least. You may still have a use for it, but generally, we find that we can do a lot without it. There's a lot of different ways you can get SQL plans. So we've stopped using it and really advise against it, and especially in a very active environment. But we have found that statement pipe and SQL text pipe are still usable, even in very active environments. So here's a little known fact, which is documented. Pipe sizes are per engine. Some people set a really high value, and then they wonder why their MONSYS statement is huge, and that's because it takes the ASE takes the pipe sizes that you specify and multiplies it by the total number of engines. So each engine has its own circular buffer. That's the reason why, which is a great thing because it reduces locking contention and things like that. So it's kind of like the pipe tables are partitioned, but with really nutty partitions where the partitions can just all of a sudden spill over and they can suddenly lose data and things like that. The total number of rows, therefore, in MONSYS statement and other pipe tables is going to be the pipe size times the number of engines on all instances. So if you have just, let's say, a SMP version of ASE and you have 16 engines, it's going to be multiplied by 16. But if you have a 3-node cluster edition and there's 16 engines on each node on the cluster edition, it's going to be 48 engines total, 48 times the pipe sizes, and that can start to really get large. Even if an engine was online, but it's not anymore, it's still going to contribute to MONSYS statement. For example, if you have an engine that was online, and then there was a lot of activity, that goes in MONSYS statement. You take that engine offline, it's still going to be in MONSYS statement. So that can so if you have a system where you're taking engines on and offline frequently, then you can still have even a bigger MONSYS statement because of that activity. So here's an example. Let's say you have 32 engines across 4 nodes in ASE's cluster edition. 18 are online, 14 are offline. Of course, engine zeros must stay online. We set the statement pipe max to 100,000. We do lots of activity, so each engine adds 100,000 rows to MONSYS statement. We now have 1.8 million rows in MONSYS statement. This is already way too much. But now let's say we swap the online and offline engines and do lots of activity. We could end up with 3.2 million rows in MONSYS statement in this example. And that's really, really way too much. And we'll talk about what isn't too much in just a moment. So, but you need to be careful with the pipe sizes. Make sure they're sized appropriately for your particular system. Now, CPU costs with MONSYS statement is something to behold. Unfortunately, MONSYS statement, the queries against MONSYS statement really do the CPU cost, really does grow super linearly as the number of rows increases. So even though the numbers here are going to be a little bit different on different platforms, different machines, different number of engines, things like that, the same kind of thing is what you're going to see is that as you start to increase the number of rows, the CPU usage of querying MONSYS statement just starts to go astronomically high. And once you pass about 200,000 or so, it really becomes an issue if you're doing real-time monitoring. And because we do real-time monitoring, Bradmark surveillance, we have to be very careful about these kinds of things. So for us, the 200,000 is kind of our end mark right there. But it really is something to consider when you're sizing your pipe tables for MONSYS statement. So as Mike mentioned, if you can use *6 to mute your line instead of using the mute button on your system, that'll be helpful for us. Fortunately, I think we're getting somebody's music there. Can you please hit *6 to mute your line? Okay, please make sure you hit *6 to mute your line when you have a chance. Otherwise, we're going to have some music here. All right. So, what is the largest batch? So some of the things when you're doing pipe sizing, you need to consider what's the largest batch you're interested in. SP configure can easily be 3,000 lines in MONSYS statement. I mean, it's probably one of the biggest procedures that come with ASE in terms of the number of lines that go in MONSYS statement. But you wouldn't expect it to run that often. You don't expect it to run all the time. So you can't sit here and hope size your pipe size for MONSYS statement based on SP configures running all the time. But you should take that into account because if an SP configure does come through, it would be nice to be able to capture all of it. So you kind of have a little bit minimum boundary of about 3,000 on the pipe size for statement pipe size. But then if you set it lower, you're going to start to miss the parts of SP configure. But if you set it too high, that can also be a problem, as we saw earlier. Because larger pipe sizes mean there's more CPU usage when querying MONSYS statement. And then of course if you have smaller pipe sizes, you're also going to have data that's aged out if there's too many statements or if there's a lot of activity going on. So it really needs to be a balance between the minimum that's needed for whatever you want as your smallest batch size and the maximum that your system can tolerate based on CPU usage, based on other types of factors as well. So for 16 to 32 engines across all instances of your cluster edition, a pipe size of about 6,000 is a nice balance, and that's what we have. That's what we recommend in Bradmark surveillance. you have at least 3,000 to handle SB configure, but you're still staying way under the 200,000 rows, even if you have 32 engines. If you have less engines, you can increase that. If you have more, like let's say you have a two engines dev system, for example, you could definitely increase that to much higher than 6,000. If you have 64 engines or higher, you're going to need to reduce that a little bit as well. Maybe set it to 4,500 or 3,000 or something. SQL text pipe size is hard to gauge for certain on a lot of systems. We use a setting that's about 3/4 of the statement pipe size. It's definitely more than adequate. You probably can get away with half or maybe even 1/4, but we do that just in case for various reasons. The SQL text pipe, though, is definitely the larger table in terms of data, total amount of data. You can really start to use up a lot of disk space if you're starting to make copies of the SQL text pipe table, MONPROCESSSQLTEXT. So something to keep in mind as well when you're sizing it, because MONPROCESSSQLTEXT definitely is much larger than MONSYSSTATEMENT. All right, so now current versus recently executed SQL. All dynamic SQL show up in MONPROCESSSQLTEXT. And again, if you can please mute your line hitting *6. I think we're hearing somebody's conversation. I appreciate it. If you can hit *6, I appreciate it. Thank you.
All guests have been muted. You can unmute your line by pressing *6.
Ed, go ahead and *6 yourself to unmute. I force muted everybody.
Hello, Mike?
Yes, go ahead.
Okay, so let's say we have an example of select 3 followed by a dynamic SQL execution of wait for delay 30 seconds. What happens is as soon as the wait for delay starts running, it will actually replace the original batch SQL in MONPROCESSSQLTEXT, which becomes exceedingly frustrating when you're looking at a MONPROCESS statement and you want to find out the original batch that created it. But in MONSYSSTATEMENT, only the original batch ever shows up. So MONSYSSTATEMENT has a much nicer behavior in this area. What you see in MONSYSSTATEMENT is actually the batch that actually ran, whereas in MONPROCESSSQLTEXT is going to show you maybe the original batch, maybe the last dynamic SQL that ran. Very confusing. In MONPROCESSSTATEMENT, as I mentioned before, CONTEXTID is all over the place, but in MONSYSSTATEMENT, CONTEXTID is a nice, well-defined counter, incremented for each procedure call. If a loop calls procedure 30,000 times, CONTEXTID will be incremented each time. If you call 15 different procedures, CONTEXTID will go up every time. MONPROCESSSTATEMENT has no primary key, as I mentioned. CONTEXTID is erratic, which causes a lot of problems. All dynamic SQL has a procedure ID of 0, line number of 1, and there's no statement number, which is really frustrating, because that would be a fantastic addition to MONPROCESSSTATEMENT. But MONSYSSTATEMENT does have a very simple PK, KPID, batch ID, statement number. And statement number is incremented. Statement number is incremented every time a statement is executed in the batch, which is a fantastic tool we'll see in a little bit. So what SQL text looks like. If you don't do an order by a MONSYSSTATEMENT, the rows actually come out in order of completion, which is fantastic. You can assign an identity column to create a row number on there, which is very useful for differentiating a certain set of statements. We'll see in a moment. SQL is written into the MONSYSSTATEMENT first, and then the statements are added to MONSYSSTATEMENT as they finish, which is an important item to note. And if dynamic SQL or procedure calls are made, then the process level will go up and then return back down. So, for example, a regular batch that comes in here, you can see the MONSYSSTATEMENT at the top and the MONSYSSTATEMENT at the bottom. You can see the wait for delay runs, and then we see in the MONSYSSTATEMENT that there's a statement ID 0, which is the first statement usually. The batch number, the KPID is there. So you can see that the first 3 columns, the KPID batch statement, are the primary key. We have a context ID of 0. It starts at 0 for the most part. Line number 1, which is the line number in the actual batch, and then we have time, CPU, wait, broken down. In this case, they actually add up properly. Sometimes they don't in MONSYSSTATEMENT and in the nest level. And this is a simplified version of what MONSYSSTATEMENT looks like. Now, in MONPROCESSSQLTEXT, we have, again, the same SQL text, and then this time we have similar kinds of things. The so far time, which is the elapsed time so far, the CPU and the wait, and the procedure is blank, context ID is 0. And this is on a good day. Now, dynamic SQL, things change. Here we have a wait for delay followed by a dynamic SQL execution. The exec call is dynamic SQL, wait for delay of another 30 seconds. So we can see here that first there's the statement ID 0. context ID 0, that's the wait for delay 30 seconds running from the first line of the text. You can see line number 1 as the physical line in the batch. Then you see that the very next item that runs is the statement ID 2. And what's happening is it's executing the dynamic SQL, the exec call, and then it's running, the exec call is actually statement ID 1. So then wait for delay runs inside the dynamic SQL. That's statement ID 2. So first that finishes, that's statement ID 2. Then that's in the context 1 because it's a call. And that's level 1 as you see on the right side. And that runs for 30 seconds. Then when that returns, ASE prints out a return line. And this is indicated in yellow. It's the last line on this particular MONSYS statement. This is a return line. Now it's gone back up to the original batch text, and now we're back at statement ID 1, and now we're going to do a summary one. Now, in some versions of ASE, you'll see CPU and wait time on the return line. In other versions, in later versions, you will not. And that's one of those behavior changes I mentioned earlier that Sybase started to do for specific reasons. I kind of wish it would still summarize, but unfortunately they started to take that out, and I think that's the direction they're going. But the time will be there. The elapsed time will be accurate, and that's going to show the elapsed time of the call that it just did. So again, so the first line was the wait for delay at the top. Second line was actually the dynamic SQL running inside the exec call, and then the last line was a summary of that exec call coming back the return line. Now, during the first wait for, this is what MONPROCESSSQLTEXT and MONPROCESSSTATEMENT looked like. And then during the second dynamic SQL call, this is what the wait for looked like in there. It's pretty much what you expect. Now, a nested procedure call. What does a nested procedure call look like? In this case, we have a wait for delay followed by an exec of BMTest1, and then inside BMTest1, it does a wait for followed by a call to BMTest2, and BMTest2 just does a wait for. So here we see now the sequence of events. The yellow line, again, indicates the return line. That's the second from the bottom. You have statement ID 0, which is the first wait for, and that runs for 30 seconds approximately. You can see it's a little bit off. Then you have statement ID 2 running. Now what this is inside the BMTest1 procedure. The first line is a wait for. That's what's running there, and you can see that ran for 30 seconds. That's in context ID 1. Context ID is nicely going up as you'd expect, very predictable. Nest level is going up nicely. After that runs, then BMTest2 is being called, and the wait for inside that one is happening, and that's statement ID 4 in context ID 2, and that runs for 30 seconds. After statement ID 4, you have statement ID 3. This is the return line inside the BMTest1 procedure. The BMTest2 has just returned to BMTest1, and it's now on that statement is doing a summary of what just happened in my call to BMTest2, and that's statement ID 3. And you can see the time is 30 seconds, and that's still inside the procedure of test 1. The very last line is the return line in this batch. So it's also a return line. It should be indicated in yellow here. But you can see statement ID 1 is actually the exec call in our original batch, and now it's a summary of what happened inside BMTest1. And BMTest1, of course, it had a 30-second delay, and then BMTest2 inside of it had a 30-second delay, so it has a total of 60 seconds coming back. And the total time for this entire batch is 90 seconds. The original wait for on the first line, followed by the exec call, which came in at 60 seconds. And you can see here the CPU and the wait times are 0, and this is in some versions it's inconsistent between the dynamic SQL versus the procedure call, but in later versions it's all pretty much consistent. The CPU time and wait time are not usable. It's just the elapsed time you're looking at on return lines. Now, if you assign a row num to MONSYS statement rows as they come back, then you can actually figure out what is a return line. Because if the statement number suddenly decreases, but the row number increases, you know you have a return line, as we saw in yellow over there. And that's very important in terms of summarization, which we'll see in just a moment. In various ASE versions, as we mentioned, the return lines are going to have different types of summaries, but Sybase is slowly taking that away, and which is fine. It's just something that it would have been nice to keep that, but I think they had certain reasons for that in different cases that have come up. So now, if you want to summarize by a batch, you just do a group by, you make the copy of MONSYS statement, and then you do a group by KPID batch ID, and you have to sum the metric values over all statement numbers, but exclude the return lines. And as we mentioned before, you can figure out what the return lines are by figuring out what statement number suddenly goes down, but yet the row num goes up. You can also summarize store procedures, but it's a lot more difficult for store procedures because you have to determine when this procedure started and when it ended. If you can figure out what the first statement number in MONSYSSTATEMENT, what's for the procedure, and then the last one is, then you can just sum over those. However, which is normally pretty easy to do because you can look at procedure ID. Procedure ID shows you which procedure you're in MONSYSSTATEMENT. But when procedure calls another procedure, the procedure ID gets replaced by that sub-procedure. So, you know, it's still no problem, right? You'll just find out the first line that mentions that procedure ID and that call, that batch ID, and you'll look at the last statement number with that batch ID and that procedure ID. That usually works, and that's a lot of examples you see on the internet have that kind of thing. But if you have a trailing call, it can be a problem. If the very last line of the procedure calls another procedure, you will not have another line after that that shows that particular statement ID. If you're ordering by batch ID statement number, if you're looking at if you were to look at the data ordered by batch ID statement number, you won't see another statement after that trailing call of the procedure. So it does take a little bit of work, but there are ways you can do this even with trailing nested procedure calls. But if procedures that aren't doing that, it's definitely much easier because then you can just look at the procedure ID, the first statement number, and the last statement number for that particular batch ID. So now a little bit about statement cache. Statement cache is an excellent new feature in ASE. In fact, they have tables devoted to statement cache that show a lot of statistics regarding, that are very much like query metrics. They show you CPU, I/O, those kinds of things. Very good tool to use for cache statements. SQL from statement cache items as they're being executed, because statement cache items are different. As they're executed, the SQL is placed in MONSYSSTATEMENT. MONSYSSTATEMENT shows a procedure call made to a lightweight procedure. ASE creates a lightweight procedure on the fly in TempDB, and then MONSYSSTATEMENT shows the calling of that procedure in there, and that's where the real work begins, in that lightweight procedure that's created in TempDB. The SQL ID is set to the statement ID of the statement cache item. RPCs are another thing that are handled differently in MONSYSSTATEMENT. If you have an RPC, they don't have an entry in MONSYSSQLTEXT. The only way to identify an RPC in the row of MONSYSSTATEMEnt, if you know it's an RPC, is by the procedure ID. And so you have to actually run object name or something on procedure ID to figure out what procedure was actually called in the RPC call. And in fact, it gets even a little bit weirder because the context ID, which normally goes from 0 to 1 to 2 to 3 to 4 and so on, it'll actually skip over a couple of them for an RPC. I have no idea where the lost context goes, but for some reason it'll go from, let's say, from 0 to 2 or something like that all of a sudden for an RPC call, whereas almost everything else, pretty much everything else, goes to context ID 0, 1, 2, 3. SQL UDFs are really problematic, however, in MONSYSSTATEMENT. If a SQL UDF is using a where clause, then MONSYSSTATEMENT will show rows, but the statistics for the SQL UDF and the statistics for the original SQL that's using the UDF, those are going to be all mixed together, and there's no way to separate them, unfortunately, in a systematic way. So it's difficult to tell what metrics are for the SQL UDF versus what are the metrics for the original, the SQL that's using the UDF. And there's definitely no return line for the SQL UDF, that would make it probably a lot easier if that was added to ASE in the future. So now I'll cover a couple of miscellaneous issues. MONSYSSTATEMENT, if you just expanded the pipe of MONSYSSTATEMENT, then all of those rows will be filled with zeros. So all of a sudden you'll end up with a kpid equals 0 for no reason until some statement has actually been run in the system. So if you have a very idle system and then you've increased the pipe size, all of a sudden you're going to see a whole ton of rows that have all zeros in them, which I think is a byproduct of how they're doing it internally. And also, when MONSYSSTATEMENT data has been aged out, the gap in statement numbers may be something you don't expect. So, for example, as we saw, the return line comes out after other lines have executed. So, let's say if a statement goes down to statement number, let's say it goes statement 20, 21, and then on number 22, let's say it was a call to a procedure. Then you're going to see a lot of statements from that procedure. And it could be a lot of them, let's say 1,000 of them, for example, in the procedure. And then when it comes back, it'll spit out a statement number 22, okay? And then the following line will be a statement number 1023, which would normally not be a problem if you have all the statements, no big deal. However, if all of those 1,000 lines were suddenly aged out of MONSYSSTATEMENT, you're going to have a statement number 22 followed by a statement 1023, and that may be the only thing you see of your particular batch. And it can get a little confusing, so that's one thing you have to handle if you write your own code to handle this. Also, select into, which is a great mechanism for copying data into historical data without logging, things like that. Select into plus union all pretty much means stack trace in ASE or corrupt data. And in fact, more often than not, corrupt data. I think in ASE, at least up until 15.5, it's still select into and union all really are kind of a toxic combination to use together. And unfortunately, there are so many uses of union all in this kind of context. So make sure you avoid that. Clock drift can be an issue. Sometimes when you do a date diff between start time and end time, you can end up with -3, -2, -1, or even little bit different values. Sometimes CPU time will be a huge value that's basically -3 unsigned long. And that's because of some kind of clock drift problem in ASE or the OS. I don't know which one it is, but it's been in ASE for a while now. I don't expect Sybase to fix it anytime soon. But if you want to read more about it, there's this particular case number on the screen here. They mention it in a where clause. And then there's a forum posting on the internet, I'm sure you can look it up, by the illustrious Jeff Tallman from 2009, talking a little bit about the clock drift problem. So that's something to be careful of, and you need to take that into account. It still affects 15.03 USD4 and 15.5 GA, maybe more. So definitely when you're querying MONPROCESSSTATEMENT and MONSYSSTATEMENT, you want to be able to fall back onto another value if you see a negative value of that difference of either 0 milliseconds or 1 milliseconds or whatever you feel is appropriate. With cluster addition, you need to be very careful about local temp DBs. As I mentioned, for example, in RPC calls, if you need to resolve an RPC name from, like, let's say, call object name procedure ID, DB ID, you do that on let's say you're on node number 1, and you do that, and the DB ID, the temp DB ID is on node number 2, you're going to get an error 969. So it's something to be careful about. You need to take that into consideration if you're on cluster addition. But it's very easy to do for statement cache items. As I mentioned before, statement cache items actually create a lightweight procedure in their local temp DB. So if you're not careful about handling that situation, you'll do an object name on that procedure ID in that lightweight procedure, and then it'll throw an error. So now for performance, I would talk a little bit about what we did in Bradmark for performance and Bradmark surveillance to make this a little bit faster and all the things we talked about. First of all, we selected into temp tables with no indexes. We found that indexes were really not very useful in our real-time aspect. But if you're doing something where you're doing more of a warehouse kind of situation, then you wouldn't run into that kind of issue. But for us, real-time, we had to not use indexes. We also had to avoid case statements because case statements are a great syntax, fantastic syntax, but over 200,000 rows, for example, CPU can really start to go up with a case statement. And we also had a dedicated data cache for our system. Normally, Bradmark surveillance uses a dedicated tempDB or something that's not the application tempDB to prevent things like log suspends and stuff like that. But we also found that we really needed a data cache dedicated to that. And we normally do that actually for other reasons, to isolate us from the I.O. from another application, for example. But in addition, for this particular purpose, it really helps performance to have some sort of data cache assigned to our tempDB that we're using for the select into. Or you can also use in-memory database, a fantastic tool that'll help it speed up even more. So for example, one of our configurations might be in a 4K logical page size database. We might have a small pool that's a 4K small pool that's about 1/3 the data cache size. This is for the tempDB we're using. We also have another large pool that's 8 times the logical page size, or 8 times 4 in this case, 32K. That might be sized to 2/3 the data cache. All the temp table activity happens in the large pool, and it'll be very quick if it's fully cached. We're not worrying too much about transaction logs since we're doing select into. Now, a fantastic resource is a white paper that was created by Jeff Tallman, the illustrious Jeff Tallman, with a very snappy title called Managing Workloads with ASE Techniques for OLTP Scaling and Performance Management with Large SMP and Shared Disk Clusters. It's a terrible title, but this paper is, I can't recommend this paper enough. If you have anything that you could possibly want to tune inside ASE, this white paper definitely has that information. It's available on Sybase.com somewhere. But it's a very fantastic tool for anything from buffer caches to logs to even cluster addition. They have, for the most part, it's a very well put together paper, very continuous. The cluster addition stuff seems a little bit tacked on, but it really covers so many different areas of ASE and tells you all sorts of fantastic tips for doing tuning on ASE. I highly recommend this white paper, and it's almost 100% correct, almost. So in conclusion, it's difficult but not impossible anymore to summarize batches and procedure in MONSYSSTATEMENT. we would like some improvements in MONPROCESSSTATEMENT if Sybase could make them, and that would definitely make it even better, but really they're still very useful tables. MONSYSSTATEMENT has gotten very good since 15.0.3 especially. It's really become a very great resource to do stuff. So when you have things that don't qualify for query metrics, when you have things that don't qualify for statement cache, if you have other things like, for example, DBCC commands will not qualify for any of that. Those kinds of things are great things to look at in MONSYSSTATEMENT, and to do the kinds of summaries that we've been talking about. And also, even in 15.7, in ASE 15.7, the MonCache procedures table actually has several new columns in it that are great columns. They tell you things like CPU and I/O and things like that. So if you have stored procedures in 15.7 that are still in the cache, you can get that information very quickly. But if they're not in the cache anymore, that's still an area where MONSYSSTATEMENT comes in very, very useful, things that are no longer in the cache. So just for a moment, I'm going to switch over to our Bradmark surveillance product just to show you what this looks like in practice a little bit. You can see here, for example, I'll bring up the store procedure activity window inside Bradmark surveillance. This is, again, a grouping of MONSYSSTATEMENT by KPID and batch ID and procedure ID, but also taking into account the trailing procedure calls and things like that. And you can see the kinds of things that you can create a summary of. You can create a summary of elapsed time, CPU time, the number of times a procedure was called, those kinds of things. In fact, there's even more. We haven't even added IOs and stuff like that to this yet. That's some area that we can add later. But it's a lot of different things you can do with procedures in all versions of ASE after 15.0.3. And then also, we can also take a look at batches. So if we wanted to summarize by batches, you can also get elapsed time from batches, and this is grouping by KPID and batch ID only. Logical reads, physical reads, rows affected. We can see bytes sent, bytes received. You get an error status, those kinds of things, memory usage. A lot of great things come out of MONSYSSTATEMENT if you summarize it the right way. If you've taken all these kinds of things into account, you can see here a couple RPCs came in here. A lot of great things can be done. You can get the full SQL text from MONSYSSTATEMENT. Fantastic resource MONSYSSTATEMENT is. So we'll just switch back over to the slides. So if you have any further questions, you can reach me at e.stungler@bradmark.com, or you can log on to bradmark.com for more information. And we do very much thank you for participating. If you want to receive Rob's fantastic ASE Quick Reference Guide, just as good as Jeff Tallman's stuff, except much shorter, much easier to use day to day. Then look for a follow-up email where we're going to ask for your preferred shipping information. And if you don't see an email in the next few days, please contact info@bradmark.com. And now we can open it up to questions.
Thank you, Ed. Appreciate the presentation very much. We have a question from Avinash who asks, what indicates that we missed text capture in SQLTEXT?
I'm sorry, could you repeat the question again?
Sure. Avinash's question is, what indicates that we missed text capture in SQLTEXT?
If you missed the SQL text in the MONSYSSTATEMENT, well, if you have MONSYSSTATEMENT rows that don't have a corresponding KPID batch ID in MONSYSSTATEMENT, then you definitely missed a SQL text in that particular table. You can take a look at for SQL text, it's a little bit more tough. In MONSYSSTATEMENT, of course, you can take a look at start times of various statements, and you can figure out how long you're really retaining data. But if you join that against MONSYSSTATEMENT, that's really the way to figure out what's the earliest SQL text that you have, what's the latest SQL text, and you can see what kind of retention period you have for that.
Great, thank you. And Avinash, I see you have your hand raised as far as the question goes. Did you have a follow-up question to that, or did we answer your question there? If you're on the telephone, *6 to unmute. Okay, I'm guessing that we got the question answered with that. Howard has a question for us. Howard, *6 to unmute your telephone, and please go ahead and ask your question. Howard, are you there? I guess not. Okay, folks, if you have a question, you can go ahead and you can ask it during the Q&A using the Q&A console, or you can use the hand-raising mechanism on the console, and we can ask the question live to Ed. And again, if you are on the telephone, you will need to *6 to unmute yourself to actually go ahead and ask the question. While we're waiting, just a question for you in general. As these MDA tables have progressed since the 12.5 series, and maybe if Rob is on the phone still too, maybe Rob would like to take a shot at this. Where do you think the biggest changes have occurred, both from a practical nature in what's available, and also to the DBA into how how much easier it is for them to be able to use the MDA tables during the day-to-day activities now and produce better results for their organization?
I think Rob has already dialed out personally because he'd be a great resource for this. But I think that since 12.5, definitely there's been a lot more tables in terms of different aspects of ASE that weren't covered originally. There were certain areas that they concentrated on in 12.5. Technically there's a lot of improvement, especially in 15.0 ESD number 2. But in terms of which information you can get out of there, I mean, a lot of the new tables come from new features. So statement cache brought new tables. IMDb brought new tables. It really, a lot of the stuff, especially, is for new features. But even for old things, they've done some improvements. They've added, as I mentioned in 15.7, they've added a lot more columns to mon-cache procedures. They've added a lot more information in various areas where they found they were deficient. In process weights, I think it is. They've added a lot more IDs for events. In 12.5, a lot of events had duplicate IDs. It was kind of ambiguous, a lot of things. They've really well-defined the weight events, especially in the latest versions of 15.
Thank you. And just following up on that, well, I think one of the biggest complaints about the MDA tables, since they were first released, is the lack of documentation as to what a lot of things mean. Do you have any secrets or insights into how people can better understand what some of the information in the table is actually about?
Yes, if you search for Sybase.com for the Sybase cases, a lot of the different behaviors of these tables are expressed there. Unfortunately, a lot of what I presented here today is not actually in those cases, but a lot of other tables are. There's a lot of great information doing different cases if you have access to that. But the documentation has gotten a lot better as well. If you look in the latest versions of the documentation, they actually, as I mentioned, the weight events, they've actually defined different weight events now. That wasn't available before, especially in 12.5. Now they show a lot of different weight events and what they mean and how to resolve some of the issues. So if you're having a physical I/O issue, it actually talks about that. It talks about the weight event name and then how to resolve it. So it's really great. The documentation is becoming better every day. If there's an area that's not good, definitely let Sybase know about it.
Great, appreciate that. Well, it's 2 o'clock, and I do not see any other questions on the console at this point. If anybody has a question at this point, go ahead and raise your hand on the console, and we'll get it answered. Otherwise, we will call it a day today. We'll give you about 10, 15 seconds. In the meantime, we just want to thank Ed and Rob and the folks from Bradmark today, especially for sponsoring today. As Ed mentioned, there will be a follow-up email that will ask for your preferred shipping information with regards to receiving a copy of Rob's fantastic book. That's now the 4th edition, is that right, Ed?
I'm sorry?
I think he's on is that the 4th edition he's got now?
I do not remember. I think he's I'm not really sure actually. Sorry.
That's okay. And many of us have got multiple editions on the shelf, so it's
on the 5th. It's the 5th edition.
Fifth edition. Fantastic, thank you. So on that, pay attention to the follow-up email. Make sure that you've got, if you don't receive in a couple of days, let Ed and the folks at Bradmark know, or contact us. You can contact me at mike@isub.com. Chances are, though, if you don't receive it, do check your junk mail and spam folders, because sometimes these emails end up there, unfortunately. But we have no more console questions. We have a couple of people thanking for the presentation. I'd like to add to that again. So everybody, have a great day. I hope this has been informative for you, and we will see you at the next meeting. Thanks, everybody, and have a great day. Bye-bye.